Okay. Yeah. Uh, Welcome everyone. Great to meet you. Yeah, it's my pleasure to have such a chance to share some of my work with you. This is Enjia Mai from Intel Corporation. My topic today is building the traceability for design and testing in Zephyr. So please kindly allow me to introduce myself briefly. My name is Enjia Mai. I'm a software engineer from Intel Zephyr team, and most of my work focuses on development and validation for Zephyr RTOS in the past 2.5 years. I used to be a Linux OS distribution developer for decades. I have to say, being able to work for open source the Zephyr project is the best wonderful things in my whole career. Why I want to share this is because we have some experimental work on building a traceability for Zephyr. So in the coming 10 minutes, I will try to bring you what is traceability and why we need traceability and how we propose to do that. And finally, a conclusion from our point of view. Okay, let's start with what is traceability. Please look at the right-hand side figure first. As you can see, this is a simplified V model. I believe most of you might be familiar with the V model, so I won't go into more detail about it. I think the point here is from the perspective of software engineering, a good quality software product or project should have design documents, implementations, and the test for all the requirements. If we can have a links between them, that will give us a clear vision of whether all the works have been done already in the software project. So the traceability means that there are links between the requirement, design, and the test. Where can we find them in Zephyr? For the requirement on the official document website, there are a detailed description of what features Zephyr can support. And we were trying to translate it to multiple requirements. I will show you this later. Okay. And there are many existing design documents for many implementation, the features, modules, or components on the official document website. We also have thousands of test cases built by many enthusiastic contributors in the Zephyr tree. Hence, our motivation is if we can link them together in a way and then show them up, we can have a clear understanding of what features we have, where they are documented, and whether they have been tested or not. By the way, you might have heard about the two pronouns called forward traceability and the backward traceability. The forward traceability means the link from the requirement to design doc and test, and vice versa. The back traceability means you can backtrack them from test to design and the requirements. Let's talk about why we need traceability. In other words, what is the benefit of having such a thing? From users' perspective, the users here means someone or companies who might use Zephyr RTOS as a production, then they might tailor the RTOS or build their applications on top of it. So they may care about what features we can use in a Zephyr RTOS and which platform or boards support this feature, and how are their status and software qualities. So we can refer to the test result to see if some dedicated features were tested well enough. Then, from developer's perspective, when the contributor add a new features in the Zephyr tree, how do we know this feature works well? It is expected to provide documentations, example samples, or test cases, and to be told how to use it. We also want to know how does it work well. It's by checking the test result or report. So these are possible benefits that we can get from having traceability. So we try to follow this guideline from Zephyr's architect, Anas Nashif. He gave this open source the best practice to us. First one, use the open source tool for managing every aspect of the project. All the invoking modules, libraries, or tool chains which use to build the traceability should be open source too. It corresponds to the spirit of the open source community and prevent you from some trouble of license. Secondly, keep the things close together. In Zephyr, documentation is generated automatically by reference to the content written in the document or code in Zephyr 3. Traceability should also work in this way. It can avoid some inconsistency and is easy to maintain. Finally, integrate with existing tools. The way to generate or present the traceability should also be integrated into the current documentation system. We don't want to have two sets of tool chain. It costs the extra effort to maintain. How we supposed to do that? Yeah, our first goal is to take advantage of the current Zephyr document as possible to build a traceability. Please look at the figures in the right-hand side to build a traceability. We need to have 3 documents in place. These are requirements, the design documents, and the test specifications. Hence, the flow of building traceability will be build a requirement docs and mark and refer to the existing design docs and build a test specification. Finally, to build a connection for all of them. Zephyr documentation generating system is mainly composed of following tools: Dogecoin and Sphinx. I think these 2 tools are used by many open source projects as their documentation system. And where can we integrate the traceability? Our idea is to put a section into the navigation pane of the Zephyr official document website. There will be 3 sections, including the software requirement, test specification, and the traceability matrix. Okay, now let's move to how we build the requirement docs. Because we don't have such a dedicated content for it yet in the official docs, but we still can find many descriptions related to these requirements on the official document. For example, the spin lock of SMP support might have a requirement like this. The system should provide a mechanism for mutual exclusion between multiple physical CPUs using a traditional spin lock primitive. So the screenshot on the right hand side shows an example of what is this requirement docs looks like. And speak of the design document are already present. We just try to find them out and then mark them in the Zephyr docs, then continue to build the requirement document. Okay. Let's talk about how we build a test specification. Zephyr already have many test cases in place, and most of them have document description for what this test case for and how it works. To make this information of test spec being completed, there would be some more fields that need to be added into the document description, such as the precondition, expected output, pass and fail criteria, etc. And the right-hand side screenshot show an example of what the test specification looks like. Okay. Once we have all these 3 documents ready, we can start to connect them to build a traceability. Okay, before we move to how to connect all of them, I would like to show you an example of what the final work product looks like. You can see the requirement on the left-hand side screenshot. For spin lock requirement just mentioned, it has a link to the top right side design specification or design doc. And it also has a link to the bottom right side test specification. Now we have a traceability from requirement to design to test. And by the way, all these things also can be folded to make this document more readable. Okay, this page shows the traceability matrix. It summarizes all the traceability. In this traceability matrix, we can easily see the link between the requirement, design document, and the test specification. And you can see a test coverage is calculated and shown. In this example, you can see a 98% test coverage, which means some requirements are not having a design or an implementation for it. So by this, we can understand the whole picture of what requirement is not implemented yet, or which requirement has been implemented but without a test case for it. Okay, so the current and the previous slide roughly show the final works product we want to provide for traceability in Zephyr. Okay, let's see how this happened behind how to build the connections. Besides the original documentation system in Zephyr, we also needed 2 extra Python modules that helps to generate some object using for providing the link. The first one is a grid. It provides many functions that are used to glue the dosgen and the Sphinx. And another one is MLS traceability. It provides the custom object that we can easily link for the documentations by the item that we specify. We also provide some visual elements such as the traceability matrix table we just saw. Take advantage of these 2 tools. We continue our work by adding item label to build all the connections between requirement, design specification, and the test specification. As you can see in the screenshot, for these 3 documents, we add a different item tag for different documents. Okay, this page shows up the flow of how traceability is being generated. And this is also a simplified flow of how Zephyr document is built. And the light blue block are current tools we are using, dosgen and the Sphinx. And the green block are extra tools we need to add, the breeze and the MLS traceability you just mentioned. And dosgen will scan all the source code in the Zephyr tree and generate many XML objects for them. Sphinx pass the IST file and the XML object from dosgen, and then build a visual element for constructing the different format of documentation, such as HTML and the LaTeX or PDF. Okay, so the breeze and the MLS traceability provide the custom XML object and are using by Sphinx. I think that's all behind it. Okay, by the way, we talk about the test result in this slide. Assume we have a traceability and know the test coverage. We also want to know how the current software quality is we usually run all the tests and get a full testing report. The Twister automation tool arms for this purpose. You can use Twister to run test automation and get the XML testing report. Now we also support JSON too. And it not only show you how many test cases are passed, fail and skip, but also the pass rate, etc. So you can also transform the XML test report to a report matrix. It shows the user-friendly test result between the test case and the hardware boards. Okay, so the final page concludes my presentation today. So have a traceability could provide us the link between the requirement, design, and the test, and the traceability matrix and the test coverage. This it aims to make the stakeholders spend less effort to build a higher quality software system. Okay, so our next step will be we will try to upstream it once some opens about the generating test specification are addressed. I believe you might be see soon.
Okay, thank you very much.
Thank you.
We have.
Thank you.
I know there's one question, so I'll pass the mic.
Thank you for all this work. It is good to see how this is coming together. One of the things that I noticed on here is I need to have traceability matrices generated per build, not per.
Oh no, yeah. I think I understand your question. You want to put them together, right? Because in my slides, you might be see two tables here. Excuse me. Is that your question? Excuse me.
So it's not even a question yet. It's just a statement. I must have tables that are only limited to the code that was built with the kconfigs applied that are on there. So if we follow the Zephyr documentation generation, that's independent of the project configuration flags. Okay, but I need to have artifacts for the project. Second thing, I need to have traceability across all the code that is built into the project, which means including my downstream modules. Right now, Zephyr documentation does, and last I knew, and it's been a little while, did not pull all the documentation that could be available in a downstream module. So there's probably some requirements on what do we need out of this that we need to pull together and make sure we get the right coverage on.
Okay.
So let me follow up on that. Do you plan on at what point when you reach the point that you're ready to present this to the project? Is that the appropriate time to have some engagement, or do you want some earlier engagement on some of this stuff here to maybe tailor it or at least put in a roadmap on capabilities?
I did have a roadmap for this. Excuse me. Yeah, because this is some of our experimental work, and but we will try to submit it after we can solve some open, and we will try to upstream them and that everyone to review it. Yeah.
Okay.
Well, the general approach here was already presented to the project 3 years ago. You know? I mean, this is nothing new here. This was discussed in the safety working group multiple times.
Well,
already.
we have a lot of people here that have come on board since that time. So.
No, I know. I mean, but it has been. I mean, this was presented to the project. I mean, you asked this question. This is already presented as part of the project and was presented in conference. I mean, this is nothing new. What I'm saying. I mean, it's not the first time this is being brought up.
Okay. Is there any other questions? Give a round. Thank you very much. Oh, wait a minute.
Thank
One
you.
question. We got one question. Hold on.
Oh, okay.
Wait, Enjia, is this like, did you present this to the safety working group recently, or is this just intel?
For me, just Intel. Yeah.
Oh,
I
okay.
think.
Just
Yeah.
wondering. Yeah, because they're working on their own separate requirement stuff going on right now. So if you guys want to get that involved in the project, they're just getting started. So before they get too far, you might want to catch them because they may be doing something different. I'm pretty sure they may be switching from. Anyways.
Okay. Okay. Yeah.
Yeah, why don't we
Thank you.
generally just plan on, because I was doing a quick scan and to see if some of the safety, oh, they're right, way in the back. Okay. So it's safer back there, yes. Okay, well, thank you very much.
Thank you.